Here's a super simple to-do app running on my server, accessible from the internet behind HTTPS. What you're looking at was provisioned, configured and deployed automatically. Not a single command was written by hand. Let me show you how. My name is Aaron. I've spent 30 years in software development. What I'm going to show you today is the exact deployment stack you can use for every app you put on the internet. It's 4 steps, fully automated, nothing done by hand. Step 1. OpenTofu to provision a new empty server. That means the server itself is defined in a file, not clicked together in some web interface. Step 2. Ansible to prepare it. Every configuration decision written down, not remembered, written down. Step 3. Docker Compose to define the runtime environment for the application. Step 4. Caddy for reverse proxying and automatic HTTPS. This is what makes your app reachable from the internet securely. The app we are deploying is a to-do list, a simple one. But the app is not the point. The point is that when every single step is code, you can reproduce it. You can verify it. If something goes wrong, and eventually something will, you can tear it down and rebuild it exactly as it was. No guesswork, no, I think I ran this command somewhere, just code. Okay, let me show you how. We're going to use Cursor for this project. I'm creating a root folder called To-Do SPA, single page application, and inside there are going to be 3 sub-projects, backend, frontend, and deployment. They are all separate projects because they are all in one folder, the LLM gets confused more easily. Inside the backend folder, the first thing is I initialize a Git repository. That's my safety net, my time machine. Every step from here is reversible. When the agent wants to run a command, you can approve it once or allow list it permanently. Most commands are safe, I'll call out which ones as we go. One instruction can trigger multiple commands, so you can expect some clicking. Now it's magic word time. The prompt: set up a backend with Node.js using PostgreSQL as the database and Docker Compose to containerize everything. This is a backend, there's a frontend coming too, so no naming conflicts and both need to run on the same machine. The first magic word is PostgreSQL. Free, open source and battle tested. There's a saying in the industry, nobody ever got fired for choosing Postgres. I also gave the LLM context about the front end. This is critical. Tell the LLM everything you know, even if it doesn't seem relevant. More context means better decisions. Depending on what's installed on your machine, it takes a while, it might take even longer, because the agent works in steps. After each one, it stops and shows you 3 buttons: undo all, keep all, or review. My rule is always read the last paragraph. That's where the agent summarizes what it did and what it plans next. If there are next steps listed, I keep the changes and say proceed. I'm not scared because I'm in a Git repo, so whatever breaks, I can undo. When allow listing, anything starting with npm or npx is safe, so you can allow list those. When the last paragraph lists results instead of next steps, we're done. That's the signal. I keep all the files and tell the LLM to commit. A commit is a save game. You can reload it if something breaks. Git commands are safe, so you can allow list those too. Everything up to this point is generic. You can start almost any project this way. Now we make it a to-do list. I asked the agent to write a markdown file describing the backend API from a front-end perspective, how to create, update, and delete to-do items. I'll be honest, I accidentally compressed 2 steps into one. I should have told it to build a to-do app first, then write the file. But it worked, so we're fine. A markdown file is just a plain text file with some formatting marks. That's not the important part. The important part is what it contains: an instruction manual that the agent writes for itself and hands it to the next step. Then commit, save the game. That's it for the backend. No spectacular results here. This video is about deployment. I'll go deeper on the backend in another video. You can close this project and open a new one to do frontend. Copy the markdown file from the backend into this folder. Then initialize an empty Git repo, and then the prompt: there's an API description in frontend-api.md. Create a React app that uses it. The user should be able to create, modify, and delete to-do items. Containerize with Docker Compose. Before we go any further, what is an API? It's an application programming interface, a specification that describes how one application uses another application's services. In our case, the front-end uses the backend's database. When we get to the deployment step, we'll use the cloud provider's API to create our server. Now, when you expose an API, you have to make sure only authorized apps can use it. You know who's asking and you know they are allowed. That's done with API tokens. A token is a username and a temporary password merged into one non-human readable string. This will make more sense when we get there. Back to the agent. It wants to run npm, the Node package manager. Harmless. Allow list everything that starts with npm and npx too. This is a big step, so it will take a while, but after it's done, don't forget to commit. It's a big change, so we need a big checkpoint. We have both components. Time to run them. And there it is, a working to-do app. Smoke tests: create a task, modify one, delete one. Smoke test is actually a term from electrical engineering. You power on a circuit briefly to see if anything burns. Here it means, does anything obviously break? Nothing does, the app works. Now we deploy it to the cloud. Third subproject, to-do deploy. Separate project because this one manages both backend and frontend. Initialize a Git repo and tell the agent right away that this project will contain OpenTofu, Ansible, Docker Compose, and Caddy. I do this on purpose. There's a file called gitignore, a list of files that must never be committed. Generated files, local configs, secrets. By telling the agent the full scope upfront, I help it build a proper ignore list from the start. Allow list almost all Git commands, the time machine always saves you. Then the most important prompt. Create a folder called infra and generate OpenTofu files that provision the smallest possible x86/AMD64 VPS in Nuremberg on Hetzner. Let me unpack that. Infra is short for infrastructure, the basic building blocks of a runtime environment. Servers, networks, databases, everything static that doesn't contain your application's logic. OpenTofu is infrastructure as code. That means instead of clicking through a cloud provider's web interface, you define your infrastructure in text files. OpenTofu reads those files and makes the API calls to provision it. The big cloud providers are Google Cloud, Amazon AWS, and Microsoft Azure. Since this video isn't sponsored, I'm using Hetzner. Smaller, less known, and €4 a month for the smallest server, which is more than enough for starting web app. x86 and AMD64. You might remember when Apple switched to their own silicon, it was a big deal. x86 and AMD64 are the traditional server architectures. I'm a fan of other architectures, but here we stick with old and tested. And why Nuremberg? Hetzner's available server types vary by location. I've used this prompt before. Nuremberg works, you don't need to specify a location. Feel free to skip that part if you don't feel comfortable with it, or choose any location close to yourself. Now, I'm not allow listing any tofu commands. If the agent tries to run a tofu command when I didn't ask for a server, something has gone wrong and I need to abort. No automatic execution for the infrastructure changes. When the agent finishes, it tells me to pass my API token on the command line. I don't like that. First, let's commit, do a save game. Then, I'll tell the agent to create a file for the token instead. Command line is tedious and somewhat unsafe. A file is much cleaner and more comfortable. I'm deliberately not reading the instructions in the last paragraph here. Don't yell at your screen. I want to show you what happens when you skip a step. As expected, an error. I didn't put the token in the file. Okay, let me do that. You can't see it obviously, because it would allow you to spend my money. Now Tofu plan works. I run tofu apply, new error. Server type CX11 not found. I don't understand that, so I do what everyone does. Copy paste the error to the agent. Tell it to search the internet for the right server types. It comes back with a guess. I try it, same error, copy paste again. This burns tokens, but here there is no other way. Next guess, CX22. At this point, I'd normally check Hetzner's website myself, but I want to show you whether the agent can figure it out alone, because if you hit something similar, you might not be able to look it up manually. So copy-paste again. The agent decides it doesn't need a server type at all, so I tried that. New error, wrong location. Copy-paste again. Then it goes back to CPX11, which we already know doesn't work. That's a warning sign. We might be going in circles, burning tokens for nothing. I give it one more try. If this fails, I'm going to ask Google or ChatGPT. If you made it so far, like the video and subscribe to bring me luck. Fingers crossed. And I got lucky. Just when I was about to give up CX23. Server provisioned. We have a running server and its IP address. I'm gonna create a subdomain todo.aaronbitwise.tech. Domain providers vary, so I'll let you handle that part your own way. Now I need automated access to this server because Ansible will run the next step remotely. That requires SSH secure shell. It can work with the username and password, but there's a better way, SSH keys. Secret keys that you upload to the server. There are many ways to generate them, I won't go down that rabbit hole, but if you get stuck, leave a comment below the video and I'll help. I tell the agent, provisioning worked, now add my SSH key so Ansible can connect. It's surprisingly hard, I get another error. Copied it to the agent and it fixed that. SSH key is now on the server. This is a checkpoint, so let's do a commit. Next, I tell the agent to create an installation folder and write an Ansible playbook. It should configure a fresh server running Debian bookworm, install Docker Compose and prepare to copy and run the app. Let me explain. Ansible installs things on a server based on configuration files. That's the part we love. A playbook is a set of those instructions. Install this, configure that, start or restart these containers. Debian Bookworm is the most popular server operating system at the moment. Debian is a flavor of Linux. Bookworm is the latest version. Debian names its releases after Toy Story characters. You actually don't have to specify the OS in your prompt. Either way works. I know that Hetzner provisions Debian by default, so I just gave it, it's up to you. I read the last paragraph, as you always should, and see that the agent created inventory.example.ini and is asking me to fill in the inventory.ini. I could tell the agent to do it, I know the IP address, but this time I'll do it myself. Open the file, select all, copy. Create a new file called inventory.ini and paste. Fill in the data. IP address comes from Hetzner's dashboard, user stays root, SSH key points to the private one, not the public one, and then save. Then copy the command the agent gave me and run it in the terminal. It doesn't work. Why? I'm already inside the installation folder, but the agent wrote the command to be run from the root. No problem, strip out the folder prefix, run it again. The first time Ansible connects to a new server, it asks, is this the machine you want? The answer is yes. Then you watch Ansible execute its tasks one by one. That's the part we love. Then commit, save the game. Here comes the most critical step. I tell the agent there is a folder above the root called todo backend. Add the step to the playbook, copy the source code to the server and start or restart the Docker containers. Read the Docker Compose YAML file to figure out what services are involved. Two things to explain here. First, why copy the source code? Because the app will change. I'll make updates and those updates need to reach the server. This is how we get them there. Second, why start and restart? When the server is fresh or recovering from a crash, the containers aren't running, they need to be started. But when we're just pushing an update, they need to be restarted. Both cases covered. Explicit is better than assumed. After a surprisingly short amount of thinking, the agent says, just run the playbook again. So I do with up arrow and enter. There's a warning I don't care about and then clean run. The backend is deployed. Commit, save the game. Now the front end. Same idea. I tell the agent there is a to-do front-end folder above the root, read its Docker Compose YAML and add it to the deployment step. Barely any thinking. Run the playbook again. It works! I get so excited at this point that I forget to commit. Instead, I go straight to the next prompt. I have a domain pointing to this server todo.aaronbitwise.tech. Add the step that sets up Caddy to reverse proxy the front end so the app is reachable on that domain. I mentioned Nginx by mistake. We don't need Nginx. Caddy handles it. Reverse proxying means this. The app is running inside containers, not directly exposed to the internet. Caddy sits in front of it, takes requests from the outside and routes them to the right place. That's also what gives us HTTPS. Automatically, no certificates to manage by hand. When the agent finishes, I'm not sure what to do next. That happens. When you are unsure, ask. I ask the agent, what's the next step? Of course, the answer is run Ansible. I knew that. But it confirms it, so I run the playbook, error. I don't even read it. Copy-paste, send it to the agent. The error was caused by the Nginx and Caddy mix-up thing, which was my fault. After some thinking, the agent fixes the playbook. I run it again. Clean! And this is exactly why we took this approach. No matter what breaks, fix the file and run again. No cryptic commands memorized. No, I think I did this somewhere. Just fix it, run it, move on. The playbook finishes. The agent says, open the browser, let's do that. Something loads and then, fail to fetch. Okay, this is where front-end debugging comes in. Press Ctrl-Alt-I, that opens the browser inspector. Click the console tab if it's not already showing. There's an error. Something about mixed sources. I'm not gonna explain it. Just copy it and paste it to the agent and say, the site opened, but I'm seeing a fetch error and here's the console message. Quick fix, run the playbook again, up arrow, enter. Smooth run. Back to the browser, refresh, and there it is. Let's do some smoke tests. Create a task, modify one, delete one. Everything works flawlessly. A to-do app running on my server, accessible from the internet, behind HTTPS, deployed without a single handwritten command. I'm not gonna lie, I'm very happy with how this turned out. We had issues, I made mistakes, but we mapped the exact process that results in success, and now you have it too. If this kind of thinking is useful to you, the why behind the how, then you'll want to subscribe to my Aaron Bitwise Weekly. Every week I pick one concept like this, something that took me years to fully understand, and explain it in 5 minutes or more. No padding, no hype, just the thing that actually matters. Link is in the description, I'll see you there.